You should be ready to check your answers to the warm-up. We're working on graphing today, so that means we need to remember how to solve for y, which is why this is your warm-up for today. So for number 1, the first thing we need to do is to subtract the 3x. So we have 2y equals, and remember we want to put the x first because solving for y generally means putting it in mx plus b form. Y still has a 2 with it, so we have to divide everything by 2. So y equals negative 3/2 x plus 5/2 would be your answer for this one. Going over to number 2. So to solve for y, we first have to move that 5x over. Since it's negative, we're going to add it. Make sure when you bring your y down, you bring that negative with it. And again, x comes first. Y is not by itself. If you needed to, you could think of it as a negative 1 here. So we're going to divide everything by negative 1. So y equals negative 5x minus 6. And that one is now solved for y. Here are the answers to the 8 problems we had for homework last night. The first 2, graphing, again, that's what we're going to be working on today. So check those lines. They already were solved for y, so you didn't have to worry about that part. Number 1 had an intercept at 6 and then slope of up 3 over 1. And number 2 had an intercept of 5 and then down 1 over 1, down 1 over 1. The bottom 6 problems were about simplifying, which meant you were looking for your like terms. A couple of things. Make sure minus negatives you change to plus a positive, which is why that's a plus 4, not a minus 4. And here, when there's a minus outside the parenthesis, it does go to each individual term. So it's 4a minus 6a, 5b minus 5b, which is why those canceled, and then 3 minus 8, which is why it's negative 5. So there are your 8 homework answers. Hopefully they went pretty well. Today we're starting chapter 9. We're going to be working on this chapter before break and after break. We're going back to our graphing and solving equation skills, so a lot of prior knowledge will be coming up here. Today we're talking about systems, which is what Unit 9 is on. So we're not just graphing anymore, we're actually solving a linear system by graphing. A system of linear equations consists of 2 or more linear equations that have the same variables. And typically when we're graphing, we deal with x and y. The solution is the ordered pair that satisfies any of the equations in the system. And again, we'll be working with two equations in a system. The values of the variables and the ordered pair make each equation in the system true. So whatever you get for that ordered pair, you can plug it into both equations and it'll give you a true equation. The first method we're going to be working on learning to solve them by is graphing. There are 2 more, and we'll be working with them this week and next. But again, first we need to understand what a system of linear equations would look like on a graph. To solve a system of linear equations by graphing, you will be given 2 equations, and we're going to graph each equation. So it's really what we've been doing, just times 2. Now, they have where they solved using the intercepts. If this method works for you, you're more than welcome to, but we are not working with intercepts. We are going to solve for y. So we're going to take their first equation, negative x plus y equals 3. And we're going to get y by itself in order to graph it. So we're going to add x to both sides. So I have y equals x plus 3. So that means I'm going to have a y-intercept of 3. And if you look at the graph, here's my y-intercept of 3. Since m isn't a number, that means it's a 1. So that means on the graph, we're going to go up 1 over 1, up 1 over 1. And that's the blue line. Now we're going to take the second equation and solve it for y. So 2x plus y equals 6. So to get y by itself, we would subtract 2x. So y equals negative 2x plus 6, which means we have a y-intercept of 6 right here. My slope is negative 2, or negative 2 over 1. So that means down 2 over 1, down 2 over 1. And that's the green line. Now, if you look at the two lines, where do you think our focus is going to be on? And that is, of course, where the two lines intersect. Since this point of intersection is on both of the lines, that means that's the point that would make them a true statement for both of them. We then label the ordered pair, which is 1, 4. And then to check it, you could plug it back into both equations and make sure that the left side is equal to the right side on both of them. And that's what they did on step 3. Since it was true, that meant the solution is the point 1, 4. So graphing, we're going to graph both lines, find where the two lines intersect, and that's going to be our answer. So let's practice one completely together. So we have x plus y equals 8 and x minus y equals 2. So we're going to take each equation and solve it for y. So the first one, we would subtract x. So I have y is equal to negative x and then plus 8. To graph this, we start with our y-intercept at 8. And then our slope is negative x, so that means negative 1. So that means we're going to go down 1 and then to the right one. And then down 1 and to the right one again. Now, because we're looking for where these two lines cross, it's going to be really important that you draw as straight of a line as possible. So using a straight edge, ruler, whatever you need to keep it as straight as possible. Unfortunately, mine won't look very great on here, but I'll do my best. And there's line number 1. Now let's look at line number 2. And I'm going to do this one in red. We have x minus y equals 2. Well, to solve for y, we're going to subtract x. So I have negative y is equal to negative x plus 2. Remember, when you have a minus, you need to bring it down. Now that means y is not by itself yet, so we have to get rid of that negative. So we're going to divide everything by negative 1. So I have y equals, well, 2 negatives makes that a positive x. Positive 2 divided by negative 1 makes that a negative 2. And now we graph this line. This time my y-intercept is negative 2. And my slope is a 1x because there's not a number here, so that means we're going to go up 1 and to the right one. So up 1 from this dot to the right one, and then continue that. And then we can use our straight edge to connect our nice straight line. We're looking for that point of intersection. So they cross right here. And that ordered pair is at 5, 3. And there's your answer. Now remember, to check it, you can plug it into both equations and make sure that the left side ends up equaling the right side for both of them. We'll be practicing some more, but we're going to talk about our special systems of linear equations right now. Special systems are how many times the lines cross each other. Our most common solution is when they cross it once, which is the one we just saw, and that has one solution. If it has a solution, then we call it consistent. If it has exactly one solution, then it's also independent. So one solution has two names for it: consistent and independent. Well, let's think about it. How many other ways could the two lines cross each other? Well, hopefully you figure out what if the lines don't cross. So if the two lines do not intersect, that means they're parallel lines, and we say that it is inconsistent, and there's no solution to it. Okay, so it can cross once, it could not cross at all, or it's what we call a dependent system. Dependent system means the lines are the same. So there's only one line. So that one would be dependent and consistent as well, because the lines go on top of each other. So there's an infinite number of solutions. So there could be one solution, infinitely many, or no solutions. That's it. If they ask you for two solutions, it's not possible. Imagine in your head, try to draw two lines, can't be curves, they have to be lines, that would cross twice. It's just not possible. It can only cross once. It can be the same line, so it would cross infinitely many, or they don't cross, which means it's no solution. So here's our visual for it, and this has the vocab words as well. So if we have exactly one thing you would know is that the slopes are different. If the slopes are different, guaranteed to have one solution. So the lines would crisscross, and we call it consistent and independent. If it has infinitely many solutions, that's consistent and dependent, because the lines depend on each other. You end up with just one line, and your description, the equations would have the same slope and the same y-intercept. So everything would be the same. Inconsistent means there are no solutions. The lines are parallel, they never intersect, and how you would tell that is the slope is the same, but the y-intercepts are different, because if the y-intercepts were the same, that would take us back to consistent and dependent. So this is a really good table to refer back to. We don't go about solving those any differently or looking at a graph any differently. It's just being able to identify how many times the lines cross. So if we look at example 2 here, on A, we're looking at x plus y equals 7, which is the blue line, and 2x plus 2y equals 6, which is the green line. Well, do the green and blue line cross? They don't, which means there's no solution and it's an inconsistent system. Example B, we're dealing with 2x plus 2y equals 6, which is the green line again, and x plus y equals 3, which is also the green line. Well, if they're the same line, then we say it has infinitely many solutions and it's consistent and dependent, because every single point on this line is a solution since the lines overlap. So you're going to take a moment to use the graph above and identify two lines that represent a linear system with exactly one solution, and identify them by the equations of the line. So go ahead, take a moment and do that, and then we'll come back and check our answers. So there are multiple options here. One option is 3x minus y equals 1, which is the purple line, and x plus y equals 7, which is the blue line. You could also say 3x minus y equals 1, the purple line again, and either equation for the green line. I'm going to use x plus y equals 3. So you could do blue and purple or green or purple. Those would be your two sets of answers for this question. So here we have two more to practice. So number 3, we're going to do it step by step, giving you a step to do it each time. And then number 4, you're going to try that all on your own. So here we're graphing and then also classifying. So on number 3, we're going to take the first equation, 2x plus 2y equals 8. And I want you to solve that for y. So go ahead, pause this, take a minute to solve for y, and then we'll move on from there. To solve this one for y, you should have subtracted 2x. So you would have had 2y equals negative 2x plus 8, since the 8's positive. Divide by 2. So y equals negative 1x, or just negative x plus 4. So now I want you to go ahead and graph that line. Make sure you're doing that in pencil, just in case something goes wrong, hopefully not. So graph it and then unpause this so we can check it. For this one, that equation, your y-intercept should be 4. And the slope was negative 1, so down 1 to the right 1, down 1 to the right 1. And again, your line should be extremely straight. And there's line number 1. Now, I want you to take the second equation, go ahead, solve for y, and then go ahead and graph it as well before you unpause this. Our second equation is x minus y equals 4. So to get y by itself, you should have subtracted x. So negative y equals negative x plus 4. And then divide both sides by negative 1. So this equation was y equals positive x minus 4. Now, looking at our two equations, one thing you should notice is the slopes are different. And remember, every time the slopes are different, you know that it's going to cross at one time, intersect at one point. It doesn't matter that the slopes are really close here. One's negative 1, one's positive 1. Since they're different, we know that we have one solution. So when you graph this, you should have started at negative 4. And then went up 1 and to the right 1. Up 1 to the right 1. And then draw a nice straight line. And now let's look at what our directions asked us for. It said to graph it and then to classify it. Well, I'm going to go ahead and label the ordered pair because that's very important. So our solution here is the point 4, 0. Remember, when ordered pairs, writing in ordered pairs, the x comes first, different than slope. Since it has one solution, that means it is consistent because it has a solution, and independent since there's only one. All right, you're going to do number 4 on your own. Check with your neighbor as you get it done. Make sure you identify what type of solution you have, and then unpause this to check how you guys did. All right, the nice thing about number 4 is they were both already solved for y. So the first equation, I'm going to put a little mark in black next to it, and the other one a mark in red. So the first one had a y-intercept of negative 4 and a slope of 2, which means 2 over 1. So up 2 over 1, up 2 over 1, and then draw as straight of a line as possible. The next one had a y-intercept of 6, and it had the same slope of 2. Now, if you look back at your chart, Immediately should have known same slope, but a different y-intercept. That means these lines are going to be parallel and not touch, but it's still said to graph it. Now the problem is if I try to go up 2 and over 1, I'm out of room. So I have to go in the complete opposite direction, which means down 2 and left 1. Draw that nice straight line again. So these have no solution since they're parallel. And no solution only has one way to classify it, which is inconsistent. So that's how you deal with special solutions. You start them the same way. It's just a matter of what the graph ends up looking like. Now, sometimes when you graph these, you're going to notice that you don't know exactly where they cross, and that means you have to estimate. And this is why graphing is not the only method we use to solve these, because it doesn't make sense to estimate if you can find another way to solve them. So if you look, and again they used intercepts, we would solve for y. But we've got the two lines here. X plus 2y equals 2 is this line, and the green line is here. So if you look very closely, you'll notice that their point of intersection is not quite in an easily labeled ordered pair. So we have to estimate. They used fractions to estimate. You're more than welcome to use decimals. Decimals make a little bit more sense when graphing because it's easier to actually label that point. Slope has to be a fraction, but points are easier as decimals. So it's just past 4. So maybe 4.25, they said 4 1/4, which is the same thing. And then it's just past -1, so they said -1 1/8. To be honest, if I were doing it, I would probably say -1.25 again. And that's why graphing doesn't always work the best, because you're not exact anymore with this. And then they did check their work. One of them came out to be exactly the same. The other one came out very close, which is fine. That's a pretty good approximation then to be that close with estimating. Last problem for the day, number 5, we're going to graph it and then estimate as best we can for the solution. So go ahead and I want you to try this problem. Again, solve for y first, and then we'll check it and make sure we did it correctly. Remember, since you're estimating your answer, you might have a little bit different answer than your neighbor, but they should be very close to each other. So pause this and work on this problem. So the first equation is x minus y equals 3. So we would subtract x. So negative y is equal to negative x plus 3. We can't leave a y with a negative because it's not alone yet. So that means we divide everything by -1. So y equals x turned positive, and then minus 3. So this one, my y-intercept is at -3. And I have a slope of 1, so that means up 1 over 1, up 1 over 1. And draw as straight of a line as possible. So hopefully you got your first line right. Second line, we have x plus 2y. Sorry, let me do this in red just so we can see the colors. So we would subtract x. So I have 2y equals negative x plus 4. Well, this time to get y by itself, we have to divide by 2. So I have y equals. Now, some of you got thrown off when we ran into negative x or just an x over 2. But remember, you can always insert an imaginary 1 there. Not imaginary, sorry, invisible. So we have negative 1/2 x and then plus 2. So this one we start at positive 2. And we go down 1 to the right 2, down 1 to the right 2. And again, making it as straight of a line as possible. So now the last thing to do is to identify what the approximate solution is. Well, notice that we're past 3, almost in the middle. I'm going to say 3.4. And then we are in between 0 and 1, but we're not quite halfway there yet, so I'm going to say 0.25 here. Now again, we're talking approximate, so your answers might have been a little bit different, but you shouldn't have had like 4 point something or 5 point something or even any negatives. It should be pretty close to 3.4 and 0.25. So tonight you're going to practice graphing. Remember, I don't want you to do it using intercepts. I want you to solve for y. So if it says anything about intercepts, just cross that part out and solve the equations for y. And then tomorrow you're going to practice this some more in class.